Okay, ma? Now see. So next concept is thermal stress developed inside a rod. See ma here. So this is a rod and initial length of the rod is at a particular temperature. So I am placing two rigid supports ma, and these supports they cannot move. So this is a rod is placed between two supports like this. Okay. It means if this rod tries to expand, the supports are not going to allow the expansion. So rod is trying to expand, but these supports they are not allowing. So therefore what happens inside the rod, a thermal stress develops. Okay, ma? And that thermal stress, so it means that some tension develops in the rod. That tension we are going to calculate. Okay. See, if I start heating this rod, okay, then the rod will try to increase its length, no ma? So actually what is the change in length? L alpha delta T. This is the relation. If I start heating this rod, if I try to change the temperature by delta T, then what is the increase in length? L alpha delta T. This should be the increase in rod if there is no rigid supports. Rigid supports lekapote, then rod should have expanded by this much. Understood, no? 1 minute. మనం కూడా జగన్ టైప్ అనమాట. వాడుకున్న వాడికి వాడుకున్నంత అరే. రిటైర్మెంట్ ఏజ్ 60 ఉంటే 62 చేస్తాడు ఆయన. మా అమ్మ లబలబల కొట్టుకుంటా ఉంది, ఇదే చేయలేకుండా నేను 62 వాళ్ళ హ్యాండ్ నుంచి చేసేది. అట్లా మనది కూడా జగన్ ప్రభుత్వమే ఇక్కడ. ఓకే మనం. So delta L is equals to L alpha delta T. This should be the change in length because of rise of temperature. Clear, no? But these supports, they are trying to compress the rod, no? They are trying to compress the rod. So here we study the concept of mechanical properties of solids. In elasticity topic, we will study a concept which is called as, clear, no? What we will study? Young's modulus is equals to F into L divided by A into delta L. This is what I will write. Okay, ma? So the ratio of stress divided by strain is called as modulus of elasticity. And if you are taking stress and strain lengthwise, then it is called as Young's modulus of elasticity. Okay. So therefore, from here also I will get one more delta L, no ma? One more delta L. What is that delta L? Delta L is equals to F into L by A into Young's modulus. I can write like this, no? F is the force developed inside the rod, or the tension which is developed inside the rod is called F. L is called original length of the rod. A is called area of cross section of the rod. Delta L is called as the compression which is produced in the rod. And this compression is produced by whom? Compression is produced by the supports. Okay. See, my rod tries to expand by 2 centimeter, then compression also must be 2 centimeter. Then only length of the rod remains the same, no? Are you able to understand, no ma? So, my father make 100 రూపాయలు ఇచ్చినాడు, ఖర్చు పెట్టుకుంటారా అని. మీ అమ్మ మెట్తో కొట్టి అవంతా తీసేసుకునింది అనమాట. మీ దగ్గర ఉన్న టోటల్ అమౌంట్ ఎంత? 0. Same condition here also. Clear, no ma? So this rod is trying to expand by 2 centimeter delta L, but rods also should compress by same amount, no ma? So compression produced is also delta L. So both should be same, no? So here this is equation number 1 and this is equation number 2. So we will write reasons also, ma. One is because of what? One is because of heating. Okay. And second equation is because of what? Because of compression. And definitely both of them must be equal. Okay. So therefore what I write? 1 should be equal to 2. So write L alpha delta T is equals to F into L by A into Young's modulus. Clear, no? I want to force. Force per unit area is equals to length and length get cancelled, no ma? So it is Y alpha delta T. So very, very, very important relation. Okay, ma? So what is meant by F per unit area? Force. The tension which is developed in the rod is called F here. Force developed per unit area. So cross section of the rod will be there, no ma? A is called cross section of this rod. Or you can call, for example, if this is a rod, ma, what is its area of cross section? So if you look from this side, you will see a circle, no? That circle area is called as area of cross section. Understood, no? So write down. So F is called as thermal force developed in the rod. Thermal force developed inside the rod. And A is called what? A is called area of cross section of the rod. Understood, no? So force per area is equals to Y alpha delta T. Clear? And force per unit area is called what? Force per unit area is called pressure, or you can call it as stress also. Clear, no? So this is thermal stress. Thermal stress produced in the rod is Y alpha delta T. If I want only thermal force or tension developed inside the rod, then what I can do? Ya alpha delta T. I can write like this also. Just this here I will take to the other side. Okay, ma? This is the tension which is developed in the rod. Ya alpha delta T. Understood, ma? That's it. Okay, ma? So this is the question given on thermal stress, ma? So see what is the data given. So a brass wire is held taut. Taut means just we are holding this brass rod without any tension. Negligible tension is called taut. So at 27 degrees between two rigid supports, its initial length is 1.8. So this is a rod, ma, which is held between two supports like this. Okay, and what is its initial temperature is 27 degrees Celsius. And what is its initial length? Initial length is 1.8 meters. So wire is cooled down to a temperature of minus 39 degrees Celsius. It means the final temperature is how much? Minus 39 degrees Celsius. Then what is the tension developed in the wire if diameter is this much? Alpha value and Young's modulus they are given. So tension is nothing but a force, no? And just now we have calculated the equation, no? What is that? Ya alpha delta T. This is the equation. Okay. So just substitute all these values. That's all. That is the calculation. So area, how can I calculate? Area is nothing but pi r square, no ma? So rods will be in the shape of cylinder, just like this pen. Okay, no ma? And what is the area of cross section of this pen? This area, pi r square. So here diameter is given, no? So I can write pi d by 2 whole square also you can write, or you can write pi d square by 4 also you can write. Okay, but diameter is given in a millimeter, no? So you can write pi by 4 multiplied by 2 into 1 millimeter is how much, ma? 10 power minus 3 meters whole square. This is the area. Understood, no? Now substitute all the values, that's it. So therefore tension developed is equals to Young's modulus is how much? 0.91 into 10 power 11. Area is how much? Pi by 4 multiplied by 2 into 10 power minus 3 whole square multiplied by alpha value 2 into 10 power minus 5 multiplied by change in temperature. Change in temperature here I will calculate, ma. Change in temperature is nothing but final temperature minus initial temperature. You can write in Celsius also, no problem, because we are discussing about the change, no ma. Change is same in Celsius also, in Kelvin also. Yesterday only we studied, no? So changes we are considering, so you need not convert again into Kelvin scale. What is the final temperature? Minus 39. Minus of initial temperature is 27. So what is the final change, ma? 40 plus 40 minus 26. 40 minus 26 is 14. Do this calculation, ma? Oh, we have to add these two, no? 39 plus 27, so 16, 6 minus 66. It means the change in temperature is how much? 66 degrees of Celsius multiplied by 66. So do this total calculation, then you will get the tension which is developed inside the wire. Understood, no? And the answer which you should get is 3.8 into 10 power 2 Newton. 3.8 into 10 power 2 Newton. That is the tension developed in the wire, in this rod. Okay, ma? So we are reducing my temperature here. We are reducing temperature means what? Length of the rod should reduce. But supports, they are not allowing the rod to reduce their length also. So automatically tension develops inside the rod. They are welded together. Held means what? We are welding the supports with this rod. So it will not allow expansion also. It will not allow compression also. That is the meaning of it.